Hi friends, I'm Mahalakshmi, Assistant Professor, St.Josephs College of Arts and Science for Women, Hosur. Now, here we will see about degrees of graph. In graph theory, degree of vertex is very interesting topic. This is very useful and important topic also. Already we know about what is graph and incidency graph and adjacency graph. Next, now we will see about a degree of a vertices. Here, the graph G, this is the graph G. Now we will check what is degree. First of all, a degree means the number of edges incident on a vertex V. Suppose that edge is self-loop means we can count twice. Degree of, again, the degree of vertex is here. Vertex in a graph G is the number of lines incident with Vi. The degree of Vi is denoted by dg of Vi. dg of G means the name of the graph name. In generally Vi. Suppose the vertex V1 means V1. The vertex V2 means V2. In generally, degree of vertex Vi is denoted by dg of Vi. Okay. Here G is the name of the graph. Otherwise, in simply we can denote D of V1, D of V2, D of V3, like that. In graph G contains 4 vertices. First one, the vertex V. The degree means how many edges are incident with that vertex. For example, the vertex V1 here is appear. How many edges is incident with the vertex V1? The first one is E1. The second one is the edge E5. The third one, the edge E3. So totally 3 edges are incident with the vertex V1. Therefore, the degree of V1 is 3. Here we can see the degree of V1 is 3. And next we can move vertex 2. Vertex 2, how many edges are incident with vertex 2? Here 1, that is E1, and 2, that is E3. So totally 2 edges are incident to the vertex V2. Therefore, the degree of V2 is 2. We can see the degree of V2 is 2. Similarly, we can find the degree of V3 and V4. And one more thing is, suppose the vertex contains a self-loop means we can count 2. For example, the degree of V3, how we can find the degree of V3? How many edges is incident with the vertex V3? The first one is E5 and the second one is E4 and the third one is E7. Totally 3, and also one self loop is appeared, that is E6. This E6 is equal to, the counting is 2. Therefore, 1, 2, 3 plus 2 means totally 5. Therefore, the vertices, degree of vertices V5 is totally 5. Simply, every self loop is equal to degree 2. This is called degree of a vertex. Degree of a vertex. Here I draw one graph. viewers, you can calculate the degree of vertex. Here one vertex is there. This is V1. This is V2. This is V3. What's the degree of vertices V1? 2 edges is incident with the vertex V1. Therefore, the degree of V1 is 2. Like that. What's the degree of vertices V2? 2 edges is incident with vertex 2. Therefore, the degree of vertex V2 is 2. And here one self loop is there. What is degree of V3? Here 1, 2 plus 2. That is plus 2 means self loop. Therefore, the degree of V3 is totally, what's the degree of V3? 4. This is called the degree of vertex. Next definition, isolated vertex. Isolated vertex means, suppose one vertex contains, suppose one vertex with degree 0 is called isolated vertex. What is degree 2 and 0? Suppose here vertex V1, V2, V3 and one more vertices is there here. That is V4. No edges is connected to this vertex. Therefore, the degree of this vertex is 0. This vertex is called isolated vertex. Next, a vertex with a degree 1 is called pendant vertex. That is, for example, here vertex V5. Vertex V5. What's the degree of this vertex? Only one edge is incident with V5. Therefore, the degree of V5 is 1. Therefore, degree of which vertices have degree 1, that vertex is called a pendant vertex. Therefore, degree of this V5 is 1. Therefore, the vertex V5 is called pendant vertex. Okay. So, isolated vertex means degree 0. Pendant vertex means degree 1. Now, using this concept, we can see one theorem. What's the theorem? See, handshaking lemma. The graph G with E number of edges and N number of vertices. Since each edge contributes 2 degree, the sum of degrees of all vertices in G is twice the number of edges in G. This is called handshaking lemma. I explain one draw one diagram. Vertex 1, V2, V3, V4. Next edge E1, E2, E3, E4 and E5. Okay. Edge 1, edge 2, edge 3, edge 4. Last one, edge 5. Okay, here the handshaking lemma tells us that here number of vertices is 4 and the number of edges is 5. Okay, each edge contributes 2 degree. That means, for example, the edge 1 is contribute 1 degree for this vertex, that is V1. This edge, the edge V1 is the edge 1. This edge is contribute 1 degree for the vertex V1 and 1 degree for the vertex V2. So every edge is contribute 2 degree. Therefore, we can easily calculate the sum of the degrees. We can calculate the sum of degrees. Sum of degrees of vertex is equal to, just we simply count the number of edges into 2, because every edge is contribute 2 degrees. Therefore, simply we can count the number of edges. Suppose here how many edges is there? 5 edges is there. Therefore, 5 into 2, 10. We can check the sum of degrees of vertex is equal to 10. For example, here vertex 1. What's the degree? 2. V3, 3. Therefore, here what's the degree of V1? That is 2. Degree of V2, that is 3. Next degree of V3, 2. Next degree of V4, 3. The sum of all degrees are equal to 2 plus 3 plus 2 plus 3, that is 10. Okay, which is equal to the number of edges, the twice the number of edges. How many edges is there? 5 edges is there. Therefore, twice of 5 is 10, which is equal to also 10. This is called handshaking lemma. We can check any, we can check in any graph. Okay. Yes. Thank you so much.